called CUNY. I'm head of the master's degree in the generative AI program, a master's degree in data science program, and we have an undergraduate degree in information science. I'm here to talk to you about hallucinations as adoption spreads very unevenly. Security and safety risks are exploding. That's the bad news. The good news, we have three people who are experts in this field who are going to talk to you about. I asked them, because we have such limited time, to tell you their favorite or most interesting hallucinations and what they did about it and what you can do to minimize those risks. So I'm going to ask each of the three panelists to very quickly introduce themselves, and then we'll get into it. So, Avi, you want to start with you?
Yeah, for sure. Thank you so much, Arthur. Hello, everyone. This is Avi. I'm a senior software engineer at Keck Medicine of USC. I'm a master's in computer science as well, and I do design data and AI platforms across Salesforce, other different products and platforms which we do have at Keck Medicine of USC. And so yeah, since we are in the healthcare ecosystem, so that's why and we are directly dealing with patients and providers at the same time. So the risk stakes are really high for us. So I quickly remember, I don't want to take much of this time, but I quickly remember there was a project which I was working on, and we got it deployed. It was really fast, fluent, and confident. And then right up until it gave a completely confident wrong answer. And that's when things changed for us. And from then on, we don't see hallucinations as a model issue. We see it as a system design flaw. I'm really excited to be part of this panel discussion, and I'll hand it off to you, Binny.
Hey guys, good afternoon. I'm Binny Gill, founder and CEO of Kognitos. We are a company we started 5 years ago, bringing English as a programming paradigm to everybody. We believe that every human is a natural programmer. If I ask somebody, give me directions to the restroom, they'll program me, go there, turn left, turn right. And we would like to bring the power of programming to everybody through AI. Deterministic AI is the core piece where I've been interested in this last 5 years. Prior to that, I've been in the enterprise B2B space, in the cloud space. I've been a long-time programmer myself. For 30 years, learning different languages, now trying to unlearn all of those languages in favor of English. Yeah.
Hey, everyone. Sorry. My name's Evan. I'm a principal scientist at a company called Relativity. And so we provide legal software to a lot of large companies around the world. And so we build like AI systems that operate on some of like the largest lawsuits and litigations in the world. The way I like to frame it is, if you've seen a lawsuit on the news, they probably used our software. And so like the kinds of risk and money involved are really, really large. And of course, there's a lot of famous sort of evidence in the news of instances in the news of lawyers basically hallucinating case law and things like that, and ruining their entire careers, losing lawsuits and so forth. We operate on tons and tons of data. We use a lot of AI, and so the risks that they can accumulate quite quickly. And so what we do is we try to manage those risks. And I like your framing of the sort of system approach, where we adopt a similar idea of making systems around the AI to manage the risk. And I would say like one of the biggest things for us is, I guess I'll just frame it this way. There are times cases that we've worked on. So we work with like, the Innocence Project to exonerate people who have been wrongfully convicted. So we've helped the Innocence Project to just exonerate someone who's in jail for 23 years. And so I just wanted to like frame this conversation in the sense of, imagine the world where people are using these AI tools and somebody is wrongfully put in jail for 23 years of their life. Do you trust your AI system to make that decision or to provide evidence for that case? And how are we going to make it trustworthy?
Okay. That brings to mind the high school student in Maryland that was put at gunpoint, slammed to the ground and handcuffed because the AI computer vision mistook his bag of Doritos for a handgun. So these things are, I think you all have your favorite horror stories. So why don't we start with you, Avi, and tell us your favorite horror story and what best methods to deal with those.
Yeah, for sure.
In 3 minutes or less.
Yeah, I'll take 3 minutes or less. So I quickly remember a few months back when me and my team, we were working on this Gen AI project for the healthcare ecosystem which we have. So we were trying to build the AI assistant, which would serve the patients with their workflow, day-to-day workflows, right? And then will help us achieve the patient 360 journey across our enterprise, and which does involve, sending out the message, secure messaging, scheduling, and then real-time data fetch from Cerner, EMRs, basically, right? And so yeah, it was on a piece of paper. That particular project looked, pretty straightforward, crisp and clear. But when we started working towards it, we actually saw lots of issues, lots of things which we should have thought about priorhand. Coming to that later in a bit. But what were all the things which we were trying to solve? We were actually trying to solve, shorten the time to care, right? Reducing the administrative burden. And then at the same time, we were trying to do call deflections with this, because our call center were achieving a lot of, they were receiving lots of calls. So, but with my previous experience when I was working on other AI projects like a year or 2 years back, right? That's when I knew that it all comes down to the data issue, right? And then if your data is clean, AI will work clean, right? So, and then there are other system designs. The architecture has to be done really good to get things to working as expected. So me and my team, we decided that we're going to just focus on the system design and architecture first, and and then we'll focus on the model which we're going to use afterwards. So when we were working on the system design and architecture, there were a few strategies which I usually tell my folks as well, and every one of you as well. So detection is really important. How and when and at what stage we need to detect whether your model is throwing out the hallucinations or no. So how we can do that? There are actually 3 buckets which we usually categorize them in. One is the model intrinsic bucket. The another one is grounding strategies, and the third one is the fundamental principles, basically, right? Model intrinsic means, let's say, we, based on a 2024 Nature Studies survey, which was done by a few folks. So it stated that when running a semantic entropy model, right? So the AI model the AI model was also confused what it was generating, right? So there were a few strategies which they adopted, right? And there were a few things which they worked upon, and that paper actually discusses about that. The another one was...
Abby, I know you're excited. Just try to summarize.
Yeah, for sure. So
data quality?
So yeah, data quality was really bad initially, to be very honest, but then we deployed some strategies. The ones which I'm talking about, we deployed RAG, right? We deployed manual testing, right? And then all those things were done in a really time-tested fashion, right? And based on that, we were able to achieve something pre-prod. Right now, it's not in prod, but still pre-prod. We were able to achieve the quality which we feel comfortable with, right? Working comfortable with. So I would say trust is really important when you're working with high-stake industries. So hallucinations is not something which you can get away with. Whether you're getting 1% or 2% hallucinations, you should treat them as
so, Abby,
really important.
I heard data quality, human in the loop, and RAG. Mm-hmm. Yes, okay. Mitty, why don't you take it over?
All right. So let me talk about this notion that you can fix hallucinations. The answer is twofold. First of all, not at all possible. Secondly, what we think is hallucination is also a question mark. Like, we are all here wearing coats. I feel coat makes me look more intelligent, but I'm no more intelligent than I was in my pajamas in the morning. Is that a hallucination? Maybe. Everything around us is a hallucination. Okay? Hallucination and intelligence are two sides of the same coin. You cannot point to any intelligent system and tell me it does not hallucinate. What you can ask, and what all of us are asking for, is it aligned with my own hallucinations? Does it believe in my own belief system? And will it do exactly what I would have done? We all know that we have been taught Newton's laws. That's also a hallucination. Einstein would tell you, I don't know what Newton was thinking. It's wrong. Yet we teach everybody, and society functions if we are aligned. So the real question is, can you align AI with human thinking? Answer there is also, as of today, no. I can go into, if I had more time, go into showing you transcripts of how I have been interacting with Claude, trying to get into its brain. It is aligned with humans, but just because humans speak language. It's not aligned with animals. It's aligned with other AIs. So that's a separate topic. If you cannot align AI with humans, what can you do? You think about how to get rid of hallucination in the first place. So there is a way of building AI in a deterministic fashion, which is what I've been working on last 5 years. We call it Neurosymbolic AI. The idea is that you start from the basis of not deep learning, start from the basis of Python, Java, C#. All of these languages never hallucinated. Why? Because they are symbolic. The challenge is those symbols only few people who call themselves developers understand. What if those symbols are actually natural language symbols, but still, when they're executed in a deterministic fashion? Now with technology, that is possible. So imagine an environment where you have standard operating procedures for your finance and accounting and legal. Instead of giving it to humans who are aligned with you, you can now give it to AI that is not aligned, but forced to follow that as if it was code. And that's how you can get rid of hallucinations, by having a platform that does that.
And if you've never heard of neurosymbolic models, don't feel bad. They're a niche type of model that has very good purposes, very practical applications in a very deterministic and defined way. And you should pursue, if you're interested in that, pursue with Binny after the session. I'll turn it over.
Yeah, so I'll start by saying that we've been using a lot of generative AI, using these commercial LLMs to analyze documents. We've been doing this in production on real lawsuits for several years now. And we've done this on tens of millions of individual documents, individual LLM calls. And the reason I bring that up is because doing it at that scale, we find a lot of really weird edge cases. And I break them down into, so we say this word hallucinations, I kind of subcategorize them because there's, I think, a couple of different ways that these models can generate false information in one way or another. The most obvious one is just outright fabrication. Hey, it's just writing something that just doesn't exist anywhere. Those things, I actually don't see them that frequently in the types of applications we build. In one respect, because at the very beginning when we were building them, we did observe them a lot until particularly GPT-4 series, around that stage of the life cycle of these models. They really improved what they called the closed domain hallucination performance. So hallucinating within the context of retrieving information from provided stuff that's in the model's context, not just openly in the world. What we have seen even still is what I call conflation, and which is the model is not outright fabricating information, but it's sort of retrieving something from the context and sort of misallocating like where it came from. So it's not inventing something, but it is saying something maybe came from a document, but it came from actually the user's instructions instead. And so that's something that's actually quite a bit more difficult for us to deal with, because it seems more pervasive than outright fabrication, but it's a little bit harder to detect as well, because it isn't false necessarily. And my favorite, this is my favorite hallucination, is incorrect inferences. So, for example, I've heard people say things like, we solve hallucination with RAG. This is nonsense, right? You can have retrieval augmented generation where you're pulling information from maybe, say, 3 or 4 different documents at a time, and then you still have these closed domain hallucination problem. But my favorite one is, if I enter a query into a system, like I'm a lawyer searching for evidence, I'm accusing Evan of stealing cookies from the cookie jar. You might have one document that said, Evan took the cookies, and you might have another one that said, this cookie jar did not belong to Evan, right? You need both of those pieces of information to prove that. However, nothing in those documents necessarily proves that it was this Evan. There's millions of Evans out there, right? And so it's possible that these models will make a claim that's not actually supported by the evidence because it's inferring in a way that I think is largely like a sycophancy problem, where it wants to prove that I did the thing, but now it's misattributing somebody else who just happens to share my name. It's allocating like that sort of evidence to the wrong person, which is obviously one of the biggest problems you could ever have in a legal context.
It's a great example of that. Inflation is a Sacramento paper is being sued by I've forgotten his name now, the NBA player who was, had a bad game, and so I don't know if you're familiar with the term of he's shooting bricks, meaning missing the basket. And then the story ran about how he broke into a house by throwing a brick through the window. Again, very important to control things. I wanted to rush through this really quickly because I really wanted to give you the opportunity to ask questions and have some dialogue, which is typically the most fun part of any sort of panel discussion, provided you cooperate, of course. You can tell I'm an academic. So if there'd be some bold person that can stand up, or if you're really bold, you can walk up to the microphone and ask a question about hallucinations or jailbreaking or anything related to that topic. We have a brave volunteer.
This question is for Binny, but anybody else can answer from the panel.
Okay.
Normally, clients or just in general, folks don't associate AI with deterministic, right? So when you are talking about deterministic AI, can you elaborate a little bit more on it?
Yeah.
I've seen the product, but I just want you all to elaborate in favor of the audience, right? What does it really mean?
So what does deterministic AI mean? Is it even compatible? So if you have seen the Star Trek series from long ago, there was Captain Kirk, who was captain of the Enterprise ship, but there was also Spock, Mr. Spock. I love Mr. Spock. Or in the later series, there was Data. Now, nobody will say that Mr. Spock or Data isn't intelligent, but they're different kind of intelligent, right? They are fundamentally logical species, but have a nice neural interface that they can talk to humans. But they don't get emotional. They don't make bad decisions based on their biases. They're very, very logical underneath. So intelligence comes in all shapes and form. The chess-playing AI intelligence, that is very different, very logical. It's a misconception that humans normally have that anything is powerful, if unknown, has to be in our shape and form. We do it with religion. When I was a kid, giant robots have to be there. They have to look like us, right? But in practice, enterprises, businesses, look at all the industrial age. None of those machines had fingers like us and all of that. We built bullet trains, airplanes, elevators, very different from humans, but very useful. So intelligence need not be like us. I think that the going for AGI is sort of not that interesting. We have to figure out how can AI be 100 times more intelligent than human at a particular thing, but cannot be general. The general intelligence comes from humans. So now, coming back to this deterministic AI, it's a kind of AI, and we are finding it with our customers in finance, order to cash, procure to pay. Money is coming in, going out, or in legal cases where you have to make sure the checklist is followed. Don't miss even a single thing. And there's an audit trail of exactly what happened. The programmatic paradigm, computer science, lasts 50 to 70 years. We cannot give that up. Computers were built because humans used to hallucinate and make mistakes in addition and multiplication, right? We can't get back to that world and say, now use it in finance. So keeping the benefit of computer symbolic computation and adding a layer that makes it now more accessible to everybody in the business, that is making AI autonomous. How can you make AI autonomous? It's something where you can just let it run. You're not worried about it. The only way to not get worried about AI is it is deterministic. And obviously, there are a lot of edge cases that happen in the real world. When the edge case happens, AI gets into a non-deterministic mode, which is an LLM mode, which is explicitly kept outside of ability of doing stuff. It'll come up with a plan, pull in a human and say, should I do it? And then human says, do it, and remember it as my deterministic instruction for next time. So that's what's happening, I think, is gaining a lot of traction these days, because people are able to just automate, move on.
Thank you. Any other questions from the audience? Please ask a question.
If not, I think we can just start talking again.
Start
I think
riffing.
we have
Start
plenty of things to
riffing.
say. I actually forgot to answer. Like, I mentioned all these problems. What do we do about it? How are we solving these problems? How do we address them? So one of the things that I feel like that sounds very silly that we do, but I think is really important is, well, it's not silly. Like, we have many different non-machine learning or non-generative AI means of verifying the information that's being presented. So the very simplest example that we employ is when we're using generative AI to extract information, we have it cite the actual source data, right? Very simple. It can hallucinate that citation, we call it. You have a simple deterministic mechanism for verifying that information did come from the source. I feel like that sounds very simple. It's a little bit harder than it sounds, but we found is that just doing that alone can mitigate a lot of the really obvious errors, and those are the ones that like really break user trust when it's like the generative AI is just doing really stupid things, super obviously wrong, and people are like, what is this? I'm not going to trust your system to do anything else. The other thing that we do is lots of sort of user experience and UI affordances that make it really easy for the human in the loop to verify things. So that, in our system, you can go in and look at the actual source information, and it's highlighted. That's like not a particularly like sophisticated thing, but it's again, just make it super quick and easy for the human to check the results. And lastly, we have some more complicated sort of validation workflows that are more like traditional machine learning.
I continue to be blown away by the fact that I think it's like between 40 and 50%, you can reduce hallucinations simply by asking the model, did you hallucinate? Again, the probabilistic model. Yes, ma'am.
Follow-up question to that. So a lot of us aren't responsible for coding the answer engine for marketers or sales or HR. We don't have that luxury of adding rules to it. So do you have any best practices for prompt writing to minimize this?
I'm sorry, for what type of writing? Prompting.
Prompting.
The previous speaker talked about the registry, which is part of an architecture that I think most organizations are starting to wake up to, which means you want to keep your semantic context and keep generative AI is a stateless technology. So the challenge is how do you keep state and keep semantic learning across your system, recognizing that models now are not only becoming more and more powerful, but they're becoming more and more the same. And so you want to try to get a sort of a model agnostic platform of which one of those things is going to be a registry where you maintain, what worked, what didn't work, what checks were used, how effective was the output, what's the quality and security constraints, and you want to keep that as part of your IP so that more of the sort of the contextual knowledge, the value creation is in your harness rather than in the model itself. Again, based on the whole concept that, as someone said before in the previous session, this is really about adopting models off the shelf, not creating models. That's where the value is, simply because most of the models right now are, disturbingly good.
Well, so let me answer that question by saying you should not be asking that question if the world moves in the direction where it is supposed to. For example, in a company where you have more than 5 people, 6 people, you're growing, we say once you have people, you got to come up with process. And we write down process in English. Why do we write down process? People are smart. And it's the opposite effect. We are telling people, we have all come to an agreement because there are so many ways of doing one thing. We're going to write down one way that all of us are going to follow, so we don't want to be creative when doing it, so that the business has a consistent outcome for anything. Now, that becomes sort of the steering wheel for the business. Anytime you want to change outcome, you go and change the process. If McDonald's wants to change the taste of a fries, they change process. They don't train 1 million cooks out there or maybe hire better cooks. In a business, humans come and go, meaning AI, the intelligence changes as people leave and join. Process stays. Same thing will happen with AI models. AI models will come and go, the process will stay. So the question around how do you learn prompt engineering, it's a very temporary phenomenon. You just have to manage AI just like you managed humans. You write down process and update process, and you need to have a platform where AI follows that very process, where it's no different between a human and AI. And next year, we will be actually talking about that being the norm. So it's just transitionary. So RAG is out, prompt engineering is out. We just have to go back to what we know best, which is human programming, as I call it. Like grandma's recipe for apple pie is a human program. Never had any bugs, and doesn't bloat over time. That's the future.
We should have a debate
Yeah,
next
it-
year about probabilistic versus deterministic models, but,
Are we allowed to disagree?
pardon?
That would
Said,
be
are we
fun.
allowed to disagree a little bit? Or
Yeah, sure.
Maybe not. Like, so I think one, I believe the question was like, hey, I might have an enterprise ChatGPT or a Copilot. I can't actually do some of the coding specifically. What can I do? You know, there's some simple tricks. You know, things like ask the model not to hallucinate. Things like employing chain of thought. So first, ask it for first a direct extraction of the evidence, then an answer, and then ask it to argue against itself. Like we do that kind of thing in our product all the time. It's quite effective. But then also, I would say there's a large component of this concept of sort of prompt engineering being an anachronism, let's say, that's going to go away. I'm not sure that's true, because I think a lot of the time what we call prompt engineering is really just being clear about what it is you want and just being specific. Because a lot of times if you have a system and you have a human language, one of the problems with human language is it's horrifically non-specific. This is the reason the legal field exists in large part because of this, right? Like people are arguing about what the English language means in a lot of times. So I think a lot of the times it's really about employing mechanisms to elicit like what the user is really trying to do in a lot of ways, because if you really are honest with yourself, a lot of what your first prompts are pretty ambiguous, and you're getting weird answers largely because you are ambiguous.
Yeah, I mean, in our undergraduate program, we actually teach prompting as a system of learning to get to sort of system thinking. What is an input? What is a trigger? What is an input? What is the data needed? What's the transformation? What's the output? What's the check? What's the security? So it has a benefit all in itself.
There's actually another thing, Arthur, which I'd like to add over here.
Please add.
I think in the kind of industries from where I'm at, the healthcare and life sciences, I think human in the loop factor, and I know some of you might not agree with this, human in the loop factor, we can't really get human out of the loop, just because there are so many things which are really at higher stakes in comparison to other industries. There might be other industries as well. So I feel there are few things which there are few processes, like sub-processes, where we might not need humans, but there are many processes where we still need humans in the loop. Is it something which we can get rid of at this point as of today? Maybe not, but maybe in the future, 5 years or 10 years down the line, right? The another thing is like the frontline staff workers, right? Nurses, CNAs and RNs, right? We can't really, at this point, I don't think we can't really, completely eradicate those with AI. So yeah, I just want to emphasize on human in the loop factor. So that is something which we still need in some part of the industries.
Thank you, Abby.
Yeah, I can touch on two topics. I mean, again, we covered that. One is prompt engineering. So prompt is also natural language. Everything else is natural language. Fundamentally, the way to make that work out is you're talking in English to a machine, an AI, and saying, you understand that, create a standard procedure for me. AI, instead of writing Python, writes English as code and shows it back to you that you gave me something ambiguous, like Grammarly corrects your grammar so that what you said becomes more precise, more understandable. That's the dialogue that has been missing. And the prompts get lost, and they are not maintained. We need to start writing programs in English, not prompts in English. Programs are the long-living assets, and AI should make that refined and more crisp and clear. And English is not meant to be free of ambiguity. But the engine that runs English can always be built in a way that it will ask a question instead of guessing its way forward. That's the thing we can do. That was a thing on the prompt thing. There was another topic you mentioned. Okay, human in the loop. Yeah, human in the loop, asking for it is an inefficient observation. Like if the human always, I'll give an example. We build sewing machines. Tailor is in the loop. If the tailor is having lunch, no shirts are being created. Then comes the shirt factory. Machines are going on. Tailor takes lunch, shirts are being created. Is human in loop required? No, only in the early days. The world where we are going is human in command, not in the loop. And that's the distinction that will happen over the next few years. And the way to get human out of the loop is to make sure that the machine is like a machine, not like something that it's a toy. It has to be deterministic. It does what it says it does so that you can focus on other things, right? So there is a way of getting it done. The AI models are already powerful enough to do 90% of the work that businesses want today. We just have to control the deterministic aspect of it.
Are there any other questions? If not, I can give you 7 minutes of your life back. Oh, I'm sorry. Yes, sir.
I kind of also thinking the prompt engineering is a concession that we have at the current stage that's the most cost-effective way to interact with AI. So I look at the beginning stage of representing assembly, and we have C, that be more higher on, and we have narrowed down to local level languages. So you kind of said it that way that there will be a programming language that's more efficient to interact with AI. So you think there would be new AI languages that we use to program?
Yeah, it will be natural language.
I mean, we already seem to be moving in that direction with meta prompting. Having the model decide what the prompt should be based on all you're doing is articulating intent. So we probably have a ways to go before we get to languages. Well, we get rid of software, essentially. We bypass it.
Arthur, can I comment for a moment?
Sure.
Yeah, I think there's the potential. I think one of the things that I try to do when I'm building AI systems is enabling some external means of verification, or the software equivalent would be something like formal verification, strong type systems, et cetera. At least in the current state, there may be, again, I would be very interested if a new language was created just for this purpose. But I think one of the sort of fundamental problems in all of this is measurement. How, in the world of very straightforward software that's stateless, measurement is somewhat straightforward. But when you're starting to do real things that interact with the world, right, you have a fundamental problem of you can never actually measure things perfectly. And then the problem sort of becomes, or sort of, I guess, reduces in a sense to, how do I know when the thing that is working is functioning as expected, right? So, because if you can do that, then you can start entering sort of self-correction loops, right, having the model fix itself. But in order to do that, you actually have to be able to measure. And that's sort of a really difficult problem in a lot of these areas, particularly with generated content where there maybe isn't actually one correct answer. There might be many, or there is nobody in the world knows the actual answer yet. So how do you do that? I don't know, personally.
I'm glad you mentioned that because, yeah, instrumentation and measurement, and that's why I tell my data science graduates, generative AI is good for you. It's not going to replace you because that just creates a need. I want to thank all three panelists for such a insightful and wonderful panel, and I wish you all a wonderful evening. I'm told that there's an open bar somewhere, so I hope I get a chance to meet you. Thank you.
Thank you.